Okay, so I'd like to go ahead and go over a few examples of our homework for this lesson. So if you notice here, we've got our piecewise functions and we want to graph them. So it tells me that when x is less than or equal to 2, that I need to graph this function to negative 2x minus 1. And I know that from what I understand about linear functions, y equals mx plus b, this b is the intercept on the y-axis, right? So I know that this function passes through the point negative 1 on the y-axis. I know that for sure. And its slope here is minus 2, and I know I'm going over to 2 and including that value, so I can go down 2 and over 1, and down 2 and over 1. And I find that's where my graph is going to be. And I know that that's defined to the left, right? That is everything that's less than or equal to 2. So I'm going to go ahead and use I'm using a protractor rather than a ruler because I find them slightly easier to use for graphing. But there's this, now we have graphed this chunk. Now I'd like to go ahead and graph this piece, and I know that here this starts out at positive 4, and then, but I don't want to graph that on here. I just know that this starts at positive 4, but our graph will begin at 2, right? We'll have an open circle at 2, but we need to figure out what the value is there. Well, starting at 4, we can use our slope to find another point, so down 1 and over 1, down 1 and over 1, and put our open circle there. Or we could actually plug 2 into this equation. I know in the notes we talked about when we evaluate, we don't plug in here, or into both of them. But because we want to know where does this really kind of start, it might not include this value of 2, but I know the open circle goes there. So if I were to plug in 2 here, I would have negative 2 plus 4, and indeed I would be at positive 2. And then my slope is negative 1, so I know to find a second point on that line, I need to go down 1 and 1 to the right. So let's go ahead and connect our line now. And there is our piecewise function. Let's try another one now that has a few more. And I want you guys to realize here that this is sketch the graph of each function. So I would like to do number 3. Because it has this negative 2 to the x as its value, or as this first function from negative 4 to anytime we're less than negative 4. So to figure out where this is going to start on my y values, right, at negative 4, where does this negative 2 to the x occur? Well, I can substitute that negative 4 into there. Negative 2 to the negative 4. And then knowing our exponent rules, that equals 1 over negative 2 to the 4. And 2 to the 4th power is going to be 16. So this is negative 1/16. So at minus 4, I have this is just right here. And this is a function that it models some exponential decay, right, because I have this negative value here. So let's go ahead and take a look at what happens when we get out a little further. Let's find a point here at negative 6. Well, using this same thing here, we know that that will be 1 over negative 2 to the 6. And so that is going to be, let me double check and make sure I'm correct, that 2 to the 6th, yes, this would be negative 1/64. So this is a very odd graph, but it actually kind of looks something like this as it comes out. But it does not matter that our graph is not perfect, because let's recall that in the directions it says this is a sketch. So a sketch of a graph is not a perfect thing, especially when we're talking about rounded curves. This is not the greatest way to describe that, but it kind of just comes up here and gets really close to this, to the x-axis, but does not touch it. It's hard for me to draw that. Okay, next section I have the negative absolute value from negative 4 to 0. And this is included here. So let's think about what is the negative absolute value of negative 4. well, that is going to be coming out of the absolute value. I get a positive 4, but it's still negative out in the front. So I'm all the way down here at -4, and I have a closed-in circle. Now recall that the function that is this absolute value goes through every single lattice point. So if we're at -4, 4, and this graph goes to 0, then I can just draw a line, it's a perfect diagonal, because recall these are perfect diagonals when they don't have any values attached. The only thing here that happened was that typically the absolute value points up as a v, but since it's negative, it's going to point down. And then here, for my last, when I'm above 0, it says here that I have 4 minus x squared. Well, if I plug in 0 here, then it tells me I start up here at +4, but my value is not included. And this is a negative parabola, so let's look at maybe, how about we come out here to 4. If we put in 4, we will have, this would become -16, so 4 minus 16, oh, that's going to be off my graph. Let's go to 2, how about that? If I plug in 2 here, I get 4 minus 4. So that is 0, so I'm already by 2, I'm down here, right? And my graph looks something kind of like that. Again, it's not perfect. These are just sketches. If you guys have any questions about this, please contact me and I can help you with the graphs. I only want you to do through number 8 on the second page. And another great resource for this would be to try to use Desmos.com. Have a great weekend.